Hello and welcome to this presentation on how to do the parametric bootstrap for a likelihood ratio difference test in Mplus when running latent class analysis. I first want to show you what the steps are of this test and then show you how you do it in Mplus. So how does this work? With a parametric bootstrap, we first of all estimate a model with C classes and a model with C-1 classes, and we calculate the likelihood ratio value in each analysis, and we calculate the difference, or we don't do this, but Mplus does it. Then Mplus uses the C-1 class model as a population model. So for example, when you compare 3 classes to 2 classes, you would assume then under the null hypothesis that the 2-class model is the true model. And in the parametric bootstrap, we use this 2-class model as a population model, and we draw samples from that population model. Many samples, we call those replications. And then in each of the bootstrap samples, we fit the C-class model and the C-1 class model, and we calculate the chi-square difference value for each bootstrap draw so that we get an empirical distribution of the likelihood ratio difference values under the null hypothesis that our 2-class model is the correct model. Then we can compare our empirical chi-square difference value that we calculated for the actual data to this empirical distribution for the delta G squared. So we're basically generating our own distribution of our test statistic and then comparing our obtained difference value for the real data to that simulated distribution. The null hypothesis that the C-1 class model fits as well as the C-class model can be rejected when the p-value is small. So meaning when you get a very small p-value, you would reject your 2-class model in favor of the 3-class model and say we need at least 3 classes to explain these data. So what does this look like in Mplus? In Mplus, you can obtain this parametric bootstrap by using the TEC14 output option and by specifying the number of bootstrap samples using the LRT bootstrap subcommand in the analysis command. And then what you should also do is you should make sure that you use enough starting values for the estimation of the C-1 and the C class model in each of the bootstrap draws. So I also use the LRT starts option here to request sufficient starts so you don't run into a local maxima or local maximum solution for any of those replications in the bootstrap. Then when you run it like this, it might take a while, and you can speed up the computations by using the processors option and requesting that more processors of your computer be used for running all those starting value sets. The output then looks like this, where you can check your random start specification for the different runs. You can also check that 1,000 bootstrap samples were completed. That is shown here at the bottom where it says successful bootstrap draws. And then at the bottom you get your results of your likelihood ratio difference test for 2 classes. That's the null hypothesis versus 3 classes. And you can see that the likelihood ratio difference value, which is called here 2 times the log likelihood difference, was 108. The degrees of freedom was given as 6. That's the difference in the number of parameters between the 2-class and the 3-class model in this case. And so that value was highly significant, as indicated by the very small approximate p-value of 0.0000 something. So the null hypothesis can be rejected. The 3-class model does fit better than the 2-class model. Mplus calls this an approximate p-value because it's based on the bootstrap. So it's a bootstrapped or simulated p-value. What you should also do is you should always check that the H0 log likelihood value, meaning the log likelihood value for the 2-class model, is the model that you also get when you run the 2-class model separately and you run it with many starts. So for example, if you compare a model with 6 classes versus 7 classes, then you could get a local maximum solution there as well. And so in order to be sure that it's the proper solution, you want to compare this log likelihood value to a value that you obtain in a separate run of this model when you just do the C-1 or K-1 class model. I hope you found this presentation useful. Check out the description for more Mplus workshops, and I'll see you next time.